Today's video is on integration using residues. In today's video, we are going to solve the problem using residue theorem. So first of all, we have to evaluate integral z minus 3 by z squared plus 2z plus 5 into dz, where c is the circle given by, first one is mod z is equal to 1, mod z plus 1 minus I is equal to 2, and mod z plus 1 plus I is equal to 2. So these are the three conditions given. So we have to solve this integral f of z dz using residue theorem. So this is the most important questions. Whatever videos I am uploading today, so these are the previous questions which are already given in the examination. Please don't neglect and practice well. And see, first of all, we have to evaluate, that is z minus 3 by this is z square plus 2z plus 5 into dz. So here integral f of z into dz. So our f of z value is this one. So f of z value is nothing but this is z minus 3 by this is z square plus 2z plus 5. First, we have to find the poles for the given function. So in order to find the poles, as usual, so we have to equate the denominator value to 0. So if I equate the denominator to 0, that is z square plus 2z plus 5 is equal to 0. As there are no factors, so I am getting the z values as minus b plus or minus root over b square minus 4ac, that is 4 into a into c by 2a, that is 2 into a value here is 1. Clear? So this is minus b plus or minus root of b square minus 4ac by 2a. That value is z is equal to minus 2 plus or minus, this is 4 minus 20 by 2a. So z value is equal to minus 2 plus or minus root minus 16, root minus 16 by 2. So z value is equal to minus 2 plus or minus root 16 value is nothing but 4 into 4, and minus 1 value is nothing but I square by 2. So this is by 2. So z value is equal to minus 2 plus or minus, this is 4i by 2. And see here, so if I cancel with 2, this is minus 1 plus or minus 2i. So z values are nothing but, so the pole values are nothing but minus 1 minus 2i, and here this is minus 1 plus 2i. So these are the simple pole values. So z is equal to minus 1 minus 2i and z is equal to minus 1 plus 2i are the simple poles. So these are the simple poles. See, now our function can be written as, so our denominator can be written as, so integral, so this is minus 1 minus 2i, and next one is minus 1 plus 2i. See, clear? Minus 1 minus 2i and minus 1 plus 2i. So these are the two pole values. So f of z can be written as, so clearly our f of z can be written as, this is z minus 3 by z minus, the pole value here is minus 1 minus 2i, and the next pole value here is minus 1 plus 2i. Clear? And now see here, so we have to see the circle equation. So for the case 1, here the circle value is problem 1, that is mod z is equal to 1. Clearly mod z value is equal to 1. Here the pole values are nothing but minus 1 comma minus 2, and here this is minus 1 comma plus 2. And now we have to plot this one. So it is also very clear. So mod z is equal to, the mod z value here is 0. First of all, the mod z value, mod z is equal to 1. So here mod z is equal to 1 is nothing but, it can be written as z minus 0 is equal to 1. So this is the circle with center 0 and radius 1. And see here, this is the circle, this is the circle with center 0 and radius 1. Clear? This is the circle 0 and center 1. And clearly our pole values are minus 1 minus 2. So here x-axis and this is y-axis, 0 1 2 3 4, this is minus 1 minus 2 minus 3 minus 4, this is I 2i 3i 4i, or else this is minus I minus 2i minus 3i minus 4i. So clearly we got mod z is equal to 0. So here, so mod z is equal to 1 here. So the radius value is 1. So here center 0 and with radius 1. So this is a circle drawn. And where are the pole values? So the pole values is are minus 1, minus 2. Here minus 1 and this is minus 2. This is minus 1 plus 2 and this is minus 1 minus 2. These are the two poles which are outside the given modulus z is equal to 1. So if they are outside, then the integral value is equal to 0. So the pole values which are interior or within the circle C are should be calculated, and therefore the residue theorem is applied. So for this case, see, for this case both the poles are outside the circle. Therefore the poles, that is minus 1 minus 2 and minus 1 plus 2, are outside the given circle mod z is equal to 1. Therefore f of z is, hence f of z is analytic. It's analytic within and on the circle. Within and on the circle. So here they are outside the circle. Hence by Cauchy's theorem, the given integral value is, so here the integral value here is the integral f of z dz value. So integral f of z dz value is equal to 0. So what is our f of z value? The question here is f of z value, that is z minus 3 by z square plus 2z plus 5. So here this is z minus 3 by, this is z square plus 2z plus 5 into dz value is equal to 0 for the case mod z is equal to 1. Clear? And the next case here is, the second case here is, see, this is z plus 1 minus I is equal to 2. So z plus 1 minus I is equal to 2. And here the pole values are nothing but, what are the pole values here? Poles are nothing but minus 1 minus 2i and next one minus 1 plus 2i. So which is nothing but minus 1 comma minus 2, this is minus 1 comma plus 2 are the pole values. And here the circle value here is mod z. So this is mod z plus 1 minus I is equal to 2, and therefore the center value I am taking as minus of. So in order to balance, this is minus 1 plus I is equal to 2. So this is the center and this is the radius. See, let me show you. So the center and the radius here is, see, so this is x-axis and this is y-axis, 1, 2, 3, 4, and this is minus 1, minus 2, minus 3, and minus 4. And here pole values I am plotting, that is minus 1, minus 2. So here this is minus 1, minus 2 is one pole value, and next one minus 1 plus 2i. So this is minus 1 plus 2i is another pole value, and circle value is nothing but minus 1 and this is plus I. So I is nothing but, so this is minus 1 comma 1. So at minus 1 comma 1, so this is the center point and we have to take 2 as radius. So after taking 2 as radius and drawing a circle, so observe which pole is inside and which pole is outside. So here the pole values are nothing but minus 1 minus 2. So this is minus 1 minus 2, and next pole value is minus 1 plus 2. So minus 1 plus 2 is within the circle C. So circle C is nothing but center minus 1 1. So this is minus 1 1 center and with radius 2. So I have drawn a circle and this value minus 1 2 is within the circle. So we have to we have to calculate the residue at this pole, and we have to use this one, residue theorem. So in order to find the pole here, the residue, so the residue value of f of z at z value is minus 1 plus 2i is nothing but, as it is a simple pole, this is limit z tends to z naught, this is z minus z naught into f of z. So clear? So this value will be limit z tends to, this is minus 1 plus 2i, and here we have to subtract this one, this is minus 1 plus 2i into what is f of z value. So f of z value is also very clear here, as f of z value is z minus 3 into, so this value is z minus 3 into, the first pole value here is minus 1 minus 2i, and the next one is z minus 1 plus 2i. So I can cancel these two and substitute minus 1 plus 2i in the remaining one. So therefore, this can be written as, in place of z I am writing minus 1 plus 2i. This is minus 3 by, in this, minus 1 plus 2i. Minus of minus, this is plus 1 plus 2i. Now I can cancel plus 1 and minus 1. So this is minus 4 plus 2i by, in the denominator also, minus 4. So minus 1 can be written as I square by 4 by 4i, plus this is 2i by, this is 4i. So if I cancel I for one time, so this will be I, plus if I cancel this I, and this is half. And according to our residue theorem, so according to our residue theorem, so we have to apply the residue theorem. According to our residue theorem, so integral f of z dz is nothing but 2 pi I into sum of the residues. Sum of the residues at interior poles. At interior poles. So here, according to this one, that is z minus 3 by z square plus 2z plus 5 into dz is nothing but 2 pi I into, the interior pole is nothing but I plus half. So if I multiply, this will be 2i, I square is minus 1, and if I cancel this 2, this will be pi I. So if I take pi common, this will be I minus 2. So this is the residue value, integral f of z dz value for mod z. See here the condition, that is mod z plus 1 minus I. So this is plus 1 minus y is equal to 2. For this circle, the residue value is this one. And the next one, and the next case here is mod z plus 1 plus I is equal to 0. So this one is mod z plus 1 plus I is equal to 0. So what we have to do with this? So here it is very clear that we got the pole values as minus 1 minus 2. So here we got pole values as minus 1 minus 2, and the next one here is minus 1 plus 2. And now here the circle value is given as, so this one is given as mod z plus 1 plus I is equal to 2. So we have to take the center value. So this is minus 1 minus I is equal to 2. So here the center value is nothing but minus 1 minus 1. And the radius here is 2. So we have to draw this one. And clearly, so this is the circle. First of all, this is x-axis and this is y-axis. 0, 1, 2, 3, 4, and minus 1, 0, minus 1, minus 2, minus 3, and minus 4. So this is also 1, 2, 3, 4, and this is minus 1, minus 2, minus 3, and minus 4. First, we have to plot the poles. So what are the poles here? Minus 1, minus 2. So this is minus 1, minus 2. Here is one pole, and minus 1 plus 2. Minus 1 plus 2 is then another pole. After plotting the poles, we have to draw the circle. So where is the center here? The center point is minus 1 and minus 1. So here is minus 1 and minus 1. So from this center, we have to take 2 as radius and draw the circle. So which pole is within the circle and which pole is outside the circle? We have to leave the outside pole and we have to calculate residue at the inside pole, and we have to use the residue theorem. So here the inside pole is nothing but minus 1 minus 2i. So here minus 1 minus 2i is within the circle, is within the given circle. So which circle it is? That is mod z plus 1 plus I is equal to 2. Now we have to calculate the residue at this point. So in order to find the residue, therefore residue of f of z at point z is equal to minus 1 minus I is nothing but, this is z minus of, we have to subtract this one, minus 1 minus I. And what is our f of z value? This is nothing but z minus 3 by z minus minus 1. So this is 2i. So this is minus 2i. And this is minus 1 minus 2i is one pole. And the next pole here is z minus, this is minus 1 plus 2i is the another pole. Now we have to, so this is plus 2i. Now we have to cancel this one, minus 1 minus 2i and minus 1 minus 2i. And we have to substitute in place of z as minus 1 minus 2i minus 3 by in place of z, that is minus 1 minus 2i, inside minus of minus plus 1, and this is minus 2i. And see, this value will be minus 4 by, so this is minus 4 minus 2i by, if I cancel this one, this is minus 4i clearly. So if I divide minus 4 by minus 4, and this is plus 2i by, this is 4i. Now if I cancel and see what happens here, minus 4 got cancelled, and this is nothing but 1 by I plus this is 1 by 2. So this can be written as 1 by I plus 1 by 2. And now I can multiply with I from the numerator as well as denominator plus half. So this value will be I by minus 1 plus half. So this is minus I plus half is the another value. So according to our residue theorem, so what is a residue theorem? According to our residue theorem, integral f of z dz is nothing but, integral f of z dz is nothing but, this is 2 pi I into sum of the residues, sum of the residues at interior poles, at interior poles. So here our value here is integral, this is z minus 3 into dz by, this value is nothing but z square plus 2z plus 5 is equal to, this is 2 pi I into minus I plus half. So if I multiply, I square is minus 1 and this is again plus 1. So the value here is plus 2 and this is 2 pi I by 2. So if I cancel this one, this value will be, this value is nothing but, this is 2 pi plus pi I. So if I take pi common, this value is 2 plus I. So this is our residue value at mod z, see here, mod z plus 1. So here is a circle, that is mod z plus 1 plus I. So this is mod z plus 1 plus I is equal to 0. At this circle, our residue value here is pi times of 2 plus I. And now let me explain you once again. So first we have to evaluate integral z minus 3 by z square plus 2z plus 5 into dz for these circles. So first of all, our f of x is nothing but z minus 3 by z square plus 2z plus 5. So in order to find the poles, I have equated the denominator to 0, and after calculating we got two simple poles, that is minus 1 minus 2 and minus 1 plus 2. These are the simple poles. First of all, I am taking mod z is equal to 1. At mod z is equal to 1, as these are the poles, minus 1 minus 2 and minus 1 plus 2 are the poles. So I have written f of z like this, and mod z is equal to 1. At mod z is equal to 1, see here the poles are outside the circle. So outside the given circle, when mod z with radius 1 and center 0, after drawing a circle, so both the poles are outside, and therefore the poles are outside the circle and f of z should be analytic within and on the given circle. And according to our integral theorem, so the integral value is 0 for mod z is equal to 1. And for the second case here, so what is the second case here? That is mod z plus 1 minus I is equal to 2. And for this case, see, so after finding the center point as minus 1 plus I, which is nothing but minus 1 plus 1. So with minus 1 and plus 1, with 2 as radius, and after drawing, so here are the two poles, minus 1 2 and minus 1 minus 2. So minus 1 2 is inside the circle, so we have to find the residue for this minus 1 and 2. So this is minus 1 plus 2i. So after cancelling minus 1 plus 2i and after substituting minus 1 plus 2i in the rest of the function, so we got the pole value as this one. So according to our residue theorem, so integral f of z dz is nothing but 2 pi I into sum of the residues at the interior points, that is 2 pi I into I plus half, so which is nothing but pi times of I minus 2. And the next case here is, the third case here is mod z plus 1 plus I is equal to 2. At mod z plus 1 plus I is equal to 2, see, let me show you. Here already the poles are minus 1 minus 2 and minus 1 plus 2. See, here is the circle equation. So we have to take the center point from this. The center is nothing but minus 1, minus 1. So with minus 1 as center, we have to draw a circle with 2 as a radius. And therefore, the two poles are minus 1, 2 and minus 1, minus 2. So minus 1, minus 2 is within the circle, and we have to calculate the pole value for this. Minus 1, minus 2i is within the circle. So minus 1, minus 2i. So we have to calculate this minus 1, minus 2i, and we have to substitute minus 1, minus 2i in the rest of the function. And after getting the pole value as minus 1 plus half, and using the residue theorem, so we have to multiply with 2 pi I, and after multiplying with 2 pi I, we got the value as pi times of 2 plus I. So this is how we have to solve. This is the essay question. Hope you all guys understand. If you clearly understand, please pass it on to your friends, practice well, and definitely this is the most important question. Please don't neglect, and I'll be uploading few questions related to residue theorem. Don't miss those and look at those videos. Thank you so much.